This is a brief paper I've written that I title Analysis. It is meant to help people understand the universe a bit better by knowing a little bit about some of the key points of its history. In 1919, when Hubble started working as an astronomer at the Mount Wilson Observatory, prevailing wisdom believed and taught that the entire universe consisted of the Milky Way. The 103-inch Hooker telescope and Hubble in 1924 discovered the Andromeda Galaxy. This work over time fueled increased interest in and investigation of the universe. Hubble's law states the greater the distance between any two galaxies, the greater the speed of their separation. By 1917, Einstein understood that his own general relativity mathematical equations required the universe must either be expanding or contracting. Einstein introduced his cosmological constant to postulate a finite, stable universe. But by 1935, when Einstein applauded, literally, under Queen Mary, if I recall correctly, the work of Lemaitre's Big Bang theory of creation of the universe, he abandoned the concept that the universe was eternal, stable, and finite. Father Georges Lemaitre proposed this Big Bang theory in 1927, later expanding it to include the creation of the universe from an extremely dense and hot cosmic egg, as he called it, or atom. Einstein opposed this expanding universe until 1935. Lemaitre, in his 1927 paper, was a genius who even articulated, quote, Hubble's law, close quote, 2 years before Hubble did. This Jesuit priest derived his Big Bang theory from his analysis of Einstein's general relativity, even while Einstein held to the view of an eternal, finite-sized, static universe. In 1935, Lemaitre even predicted that cosmic rays may be leftover artifacts of the Big Bang creation of the universe. Before his death in a hospital in Switzerland in 1966, Lemaitre learned of proof of his theory by Penzias and Wilson. When Penzias and Wilson in 1964 discovered the smoking gun of cosmic microwave background radiation, they provided definitive proof of a, quote, Big Bang, currently calculated as approximately occurring 13.7 billion years ago. What science has not moved past is that there wasn't just one Big Bang. There are endless Big Bangs and Big Crunches. And science has not yet incorporated my scalar particle theory into its calculations. But it soon will, because I am a most unusual and profoundly clever genius. That's my story, and I'm sticking to it. This residual cosmic microwave background radiation was predicted by Gamow and Aylford in 1948 in their famous cosmogony paper, which importantly advanced the Big Bang theory of the creation of the universe. That paper outlined with great prescience their predictions about the universe's relative percentages of hydrogen and helium. Moreover, perhaps most astonishingly, said paper predicted that the afterglow of this Big Bang would now result in a universe-wide temperature of 5 degrees Kelvin above absolute zero. 16 years later, it was determined the universe-wide temperature is 2.7 degrees Kelvin above absolute zero. We can forgive their slight error. Subsequent cosmic inflation theory, worked by Guth, who in 1981 proposed the idea that the nascent universe passed through a phase of exponential expansion that was driven by a relative negative vacuum energy density, that is, paren, positive vacuum pressure, close paren. The results of the WMAP mission in 2006 made the case for cosmic inflation seem very compelling. Except to me. Assuming arguendo that Friedman, Lemaitre, Einstein, Gamow, Aylford, Hubble, Penzias, Wilson, et al. Have brought genius insights into furthering mankind's understanding of the universe, then what? Well, the answer is that we will develop as long as sentient humans and or machines exist, new, better approximations of the realities of our universe. Hoyle's concept of nucleosynthesis within stars was first published in 1946. This explained convincingly the presence in the universe of elements heavier than helium. In 1948, when Gamow and Alpher published a paper postulating that hydrogen and helium, in their predicted proportions, as since confirmed, had to have been created in the Big Bang, science took a giant leap forward. Hoyle advanced this work by his theory that the rarer elements have been created in supernovas. Although Gamow-Alpher's Big Bang and Hoyle's steady-state theories have always been vigorously debated, they both have been key elements advancing our comprehension of the history and future of the universe. Both of these theories have informed me in developing my own inchoate cosmological research, experiments, and theories.